Hello friends, welcome to our channel. Today we shall discuss on the radius of curvature in Cartesian form. So in order to consider the radius of curvature in Cartesian form, as we know that the Cartesian equation is given by, Cartesian equation is of the form y is equal to f of x. So this is the Cartesian equation is of the form y is equal to f of x for the curve. So to discuss the radius of curvature, so let us consider a simple graph with the two axes, that is x and y axis. So this is the y axis and this is the x axis, and the O to be the origin. So then to consider the curve, first we shall construct a straight line. So this is the given straight line. So the angle made by any straight line, it is taken as a phi. So then we shall draw the curve on this line. So this will be the curve, that is C. So C is the curve. So then first thing is that we have y dash is equal to dy by dx is nothing but tan phi. The dy by dx is nothing but it is equal to tan phi, and similarly the double differentiation. So the second order differentiation, that is y double dash is equal to d square y upon dx square. So if you differentiate tan phi, then it will be sec square phi into d phi by dx. So then the sec square phi can be written as, so this is the sec square phi can be written as 1 plus tan square phi. So then we can substitute, that is y double dash can be written as 1 plus tan square phi into d phi by ds into d phi by dx. So that is d phi by dx can also be written as, d phi divided by ds into ds upon dx, because ds and ds get cancelled and the remaining will be d phi upon dx. So we can write it as ds into ds upon dx. So it is nothing but just d phi by dx. And we know that ds upon dx is nothing but it is 1 plus dy upon dx the whole square. So these are the equations of the curvature. So then as we know that y dash is nothing but dy by dx is nothing but tan phi. Similarly we have found the first differentiation. So this is nothing but y dash. Now we shall find the second order derivative. The second order, it will be d square y upon dx square is equal to 1 plus dy upon dx whole square into d phi upon ds into 1 plus dy upon dx the whole square can be written as, means differentiating this you need to find the second order derivative. So just we have differentiated, that is square root of 1 plus dy upon dx whole square can be written as 1 plus dy upon dx whole square into, it is d phi upon ds. So d phi upon ds into, then keeping this as it is, so that is 1 plus dy upon dx the whole square. So that is ds upon d phi. ds upon d phi can be written as, so here it is square root of 1 plus dy upon dx whole square can be written as 1 plus dy upon dx whole square. So square root can be written, it can be written as 1 by 2 divided by, so that is square root can be, so just we have 2 times 1 plus dy upon dx whole square. So we have just written it only once, 1 plus dy upon dx whole square. So this square root is replaced by 1 by 2 and the remaining is d square y upon dx square. That is, we have just found the d phi upon ds. That is, d phi upon ds, when it is written on the right hand side, it will be ds upon d phi. So that is, ds upon d phi is equal to, so 1 plus dy upon dx the whole square. That is, we have two repeated terms, so it is just written once. Then the square root is written as 1 by 2 divided by, so this will be d square y upon dx square. So therefore you can write it as the rho. The radius of curvature, it is denoted by rho. Therefore rho is nothing but it is ds upon d phi. Because the curvature C is nothing but d phi upon ds. But we need to find the radius of curvature. That is, the curvature K is given as d phi upon ds. But what about radius of curvature? What about radius of curvature is that it is the reciprocal of curvature. So it is 1 by k. So 1 by k is nothing but ds upon d phi. So therefore ultimately we have found the ds upon d phi. It is equal to 1 plus. So what about dy upon dx? So y dash is nothing but it is dy upon dx. That is the first differentiation. So just replace dy upon dx with y dash. That is y dash whole square. Then raised to. So it is 1 by 2 and that is, we have 2 and 1 by 2. So we have the square, so therefore it will be 3 divided by 2 divided by. So it is d square y. So y double dash is nothing but it is d square y upon dx square. So therefore it is written, just replace it with y double dash. So here we have square and we have square root. One square root get cancelled. So therefore the remaining will be 3 by 2. So this is the required equation for the radius of curvature in Cartesian form. So that is, rho is equal to ds upon d phi is nothing but 1 plus y dash is nothing but dy upon dx whole square raised to 3 by 2 divided by d square y upon dx square is nothing but y double dash. So this is the radius of curvature for the Cartesian form. So then we shall consider one note, that is, when y dash is equal to infinity, then what will be the radius of curvature? That is, then rho can be written as, then rho is equal to, it will be 1 plus, when y dash will be infinity. So when y dash means dy upon dx when it is infinity. So we can write y dash, we can write it as dx upon dy the whole square raised to 3 by 2 divided by. Similarly, when you consider y dash to be infinity, so we need to replace y double dash also. So therefore it will be, just when y dash is infinity means dy will be infinity. So therefore just we need to exchange the numerator and denominator. So when y dash is dy upon dx, when y dash is infinity, then it will be written as dx upon dy whole square. Similarly, y double dash will be dx upon, that is second order derivative. So it will be d square x upon dy square. So this is the equation of a radius of curvature in Cartesian form when y dash is infinity. So when y dash is infinity, then it has to be represented with x dash. So x dash can be written as dx upon dy. So when y dash is infinity, we have just replaced y dash with x dash. X dash is nothing but dx upon dy whole square. Similarly, x double dash will be equal to d square x upon dy square. Thank you friends. Subscribe our channel for more updates.